Okay, number 45. A 5-kilogram bowling ball strikes a stationary bowling pin. After the collision, the ball and the pin move in the direction as shown, and the magnitude of the pin's momentum is 18 kilogram meters per second. What's the velocity of the ball before the collision? So I populated this a little bit. So we want the velocity of the ball before the collision. So that would be V1. All right, so we know that the ball does have a momentum in the x direction before, but we just don't know what it is. But we know in the y direction it's going to be 0. And the pin is not moving at all initially, so that's 0 and 0. The ball, all we have is an angle. We can't do anything with that. And now we have the pin after the collision. We would have in the x direction, we're going to have cosine 30 times 18. And in the y direction, it would be sine 30 times 18. So cosine 30 times 18 looks like it's 15.6. And sine 30 times 18, sine of 30 is a half, so we're going to go with 9. So let's write our conservation of energy in the x and y direction. All right, so I've written the two equations for conservation of momentum in the y and x direction. And let's see, the ball, P1x, we don't know. P1x. P2x is 0. P1x prime we don't know as well. And P2 prime x is going to be 15.6. In the y direction, P1y, that's 0. P2y is also 0. P1 in the y direction we don't know, so we have 0 equals P1 prime y plus P2 prime y plus, oh, hang on. Yeah, we made a little mistake back here. The pin moves in a negative 9 direction. So this is going to be minus 9. So P prime 1y equals 9. All right, so we have a little issue here because we have 3 different unknowns. But we can look at this and say, okay, P1 in the x direction, final, goes this way, and P1 prime in a y direction is equal to 9. And they did give us the angle. They said that was 53.1. So we have a relationship between opposite and adjacent, which is tan. So tan theta equals the opposite over the adjacent. So if we solve for P1x prime, we're going to get 9 divided by tangent of 53.1 degrees, which is 9 divided by 1.33, or 9 divided by 1.33, and that's going to be equal to 6.8. So we have a momentum in the x initial momentum. All right, so we have the final momentum for P1 in the x direction of 6.8. Let's get some room here. Whoops. We want to erase this. So let's solve for P1x equals P1x prime, which we said was 6.8, plus 15.6. So the momentum in the x direction of the ball initially is 6.8 plus 15.6, which is 22.4. Well, they didn't ask us for the initial momentum. They asked us for the velocity initially of the ball. So if we know momentum equals mass divided by, mass times velocity. So velocity is going to equal momentum divided by mass. The momentum is 22.4, and the mass they gave us was 5. So we're coming up with a velocity of 4.48 meters per second.